Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar. And you welcome back to this study. Dear student, in this first video lecture of week 11th for the course Biostatistics 1, today we are going to learn about laws or theorems of probability. So first of all, I would like to tell you about the probability of a complement event. Probability of complement event. So there is a theorem related to the probability of the complement of an event. So the statement of the theorem is probability of impossible event is 0. That is, probability of the empty set is equal to 0. Now to prove this theorem, impossible event contains no sample point and hence the certain event S and the impossible event pi are mutually exclusive. So sample space S union empty set is equal to S. So taking the probability, we have probability of S union pi is equal to probability of the sample space S, and this implies that probability of the sample space S plus probability of pi set is equal to probability of the sample space S, and this implies that probability of the pi set is equal to 0. Now this is the complement of an event, and this is the probability of the complement of an event. Suppose we have an event A, so A bar is actually the complement of the event A, and the theorem statement is a probability of the complement event A of A is given by probability of the complement of event A is equal to 1 minus probability of event A. Now for the proof, since the event A and the complement of event A are disjoint sets. Disjoint sets mean that these two events, these two sets A and A complement have no common element. This is called disjoint set. Two sets are called disjoint sets when they have no common element. Moreover, the union of these two sets A union A complement is equal to S, where S is the sample space. Now taking the probability on both sides, we have probability of A union A complement is equal to probability of the sample space S, and as we know that probability of the sample space S is equal to 1, so probability of A plus probability of A complement is equal to 1. Now probability of A complement is equal to 1 minus probability of event A. So dear students, note that this is actually the probability of A plus probability of A complement is equal to 1. As we know that probability of the sample space S is equal to 1, so putting here in the right hand side this is equal to 1, and now the probability of A union A complement can be written as probability of A plus probability of A complement is equal to 1. In the coming slide, we will learn about this law, that the probability of union of two sets, for example A is one set and B is another set, then probability of A union B can be written as probability of A plus probability of B. This is actually called the additional law. In the coming slide, we will discuss additional law. So dear students, now since probability of A plus probability of A complement is equal to 1, replace probability of sample space S by 1. Probability of the sample space S is equal to 1, so putting here this is equal to 1, and probability of A union A complement can be written as probability of A plus probability of A complement. Now we can write probability of A complement is equal to 1 minus probability of A, and this is the proof of the theorem. Now example related to this theorem, related to this law: a coin is tossed 4 times in succession. What is the probability that at least one hit occur? So dear students, in the previous video lecture of week 10, I have already told you that for finding the probability of an event, first of all we construct the sample space for the outcome of an experiment. Now in this experiment we have a coin and the coin is tossed 4 times. So there will be 2 power 4, because the sample space for this experiment consists of 2 power 4 is equal to 16. So there will be 16 sample points, as each toss can result in 2 outcomes, and we assume that each outcome is equally likely. So for this experiment the sample space contain 16 outcome, because there are 2 outcome for a coin, one is head and other is tail, and we toss the coin 4 times, so 2 power 4 is equal to 16. Now in this experiment the sample space has 16 outcomes, and we have to find the probability that at least one head appear. Now in this case our choice probability, the number of outcomes of our choice, actually our choice is at least one head. So at least one head appear. When at least one head appear, according to this statement, there are 15 outcomes in which at least one head will be appear for this sample space which have 16 outcomes. Now if we use the statement if we use the opposite statement, that suppose no head appear, then this will be actually the complement of our choice event. Let A be the event that at least one head appear, and this event A contains our choice outcomes. So this event A has 16 outcomes in which there exists at least one head. Now suppose A complement is the event that had no head occur, and A complement has the single sample point, which is this tail, tail, tail and tail. For the first time we may contain tail. For the second time we may contain tail. Similarly for the third time tail, for the fourth time tail. So this is the only one outcome in which there is no head appear. So if A is the event that at least one head appear, for this statement that at least one head appear, we use the event A. Now for no head appear, we use the A complement. Now since the number of outcome for this event A is only 1, so the probability for this outcome is very easy. So the probability of the complement of A is equal to 1 over 16. So in the sample space we can easily search the complement of our choice event. So for this purpose we use the complement of an event. For this purpose we use this law. Sometime the search of our choice in the sample space may be difficult, so in that case we use the reverse statement. We use the complement statement for our choice. So for this purpose we use the complement law. Now the probability of the complement of event A is equal to 1 over 16. Now using this law, probability of A is equal to 1 minus probability of A complement. So probability of A is equal to 1 minus, and the probability of A complement is 1 over 16. Now the probability of A is equal to 15 by 16. Since in this problem I have already told you that the number of outcome in our choice event is 15, but sometime it will be difficult for us to find the number of outcome in our choice event. So For in this case, we can use the complement set. Now, uh, another law, which is called probability of sub-events. For this sub-events, we have a theorem: if A and B are two events such that A is a subset of B, then the probability of A will be less than or equal to probability of B. For A is a subset of B, the event B may be written as the union of two mutually exclusive events, B intersection A and B intersection A complement. So B is equal to B intersection A union B intersection A complement. But we know that B intersection A is equal to A, so B is equal to A union and B intersection A complement. So dear student, this is the Venn diagram. This is the universal set. This is the rectangle box represent the universal set, and this one circle represent set B, and this is the set A, because set A is a subset of B. So you see over here, this circle is actually lies in this circle B. So circle A is the subset of B. So set A is the subset of set B. This is the representation of two subsets by Venn diagram. A is the subset of B. Now, therefore, probability of B is equal to B probability of A union B intersection A complement. And we know that probability of A union B intersection A complement. So replace this union by addition. Probability of A plus probability of B intersection A complement. But probability of B intersection A complement greater than or equal to 0. Hence, probability of A less than or equal to probability of B. Now, another theorem: for any two events A and B, then probability of A complement intersection B is equal to probability of B minus probability of A intersection B. The events A complement intersection B and A intersection B are mutually exclusive. Mutually exclusive mean that the event has no common element. The events are disjoint event called mutually exclusive events, and their union is B. So A complement intersection B and A intersection B are mutually exclusive, and their union is equal to B. That is, A intersection B union A complement intersection B is equal to B. Now, taking the probability on both sides, we have probability of A intersection B union A complement intersection B is equal to probability of B. Now, change this union by addition. So probability of A intersection B plus probability of A complement intersection B is equal to probability of B. So probability of A complement intersection B is equal to probability of B minus probability of A intersection B. And this is the proof of the theorem. And you see over here, this is actually the Venn diagram. This is the common portion for two events A and B. A and this portion represent A intersection B, and this is the A complement intersection B, and this is A intersection B complement. So this is actually the event A, and this is the event B. Now, another theorem: if A and B are any two events defined in a sample space S, then probability of A intersection B complement is equal to probability of A minus probability of A intersection B. Now, the events A intersection B complement and A intersection B are mutually exclusive events, and their union is equal to A. So, in the next coming slide, we have probability we have A intersection B is equal to A intersection B complement is equal to A. Now, taking the probability on both sides, probability of A intersection B union A intersection B complement is equal to probability of A. Now, replace this union by addition. So probability of A intersection B plus probability of A intersection B complement is equal to probability of A. and hence probability of A intersection B complement is equal to probability of A minus probability of A intersection B. Now this is the addition law of probability. Addition law of probability statements say that if A and B are two non-mutually exclusive events, non-mutually exclusive event mean that these two events have some common outcomes, so called non-mutually exclusive event. So A probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So this is actually called the additional law for non-mutually exclusive event. If these two events A and B are mutually exclusive, then the probability of A intersection B will be equal to 0. So the additional law become probability of A union B is equal to probability of A plus probability of B. Taking the help from the above diagram you see over here in this slide, so using this diagram we have A union B is equal to A union A complement intersection B. Now taking the since the events A and A complement intersection B are mutually exclusive, so probability of A union B is equal to probability of A union A complement intersection B. Now probability of A union B is equal to probability of A plus probability of A complement intersection B. Replace this union by addition, because now since these two events A and A complement intersection B are mutually exclusive. Now since A complement intersection B and A intersection B are disjoint events and their union is B, so B is equal to A intersection B union A complement intersection B. Now taking the probability on both sides, we have probability of B is equal to probability of A intersection B union A complement intersection B. So replace this union by addition, probability of A intersection B plus probability of A complement intersection B. Now probability of A complement intersection B is equal to probability of B minus probability of A intersection B. Putting the value of probability of A and complement intersection B is equal to probability of B minus probability of A intersection B in this equation number 1, we have probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, and this is the proof of the additional law of probability for two non-mutually exclusive event. Now suppose A and B are mutually exclusive event, then the probability, the additional law will be equal to probability of A union B is equal to probability of A plus probability of B, because probability of A intersection B is equal to 0 in case of when these two events A and B are mutually exclusive. Mutually exclusive mean that these two events A and B have no common element. Have no common element mean A intersection B will be equal to pi, and I have already told you in the first slide of this video lecture that probability of the empty set is equal to 0. So putting here 0, we have probability of A and B is equal to probability of A plus probability of B. Now two independent events. When the occurrence of one of the event has no effect on the probability of the occurrence of the other event, then the two events are called independent events. Now the multiplication law of probability for two independent and not mutually exclusive events will be, suppose A and B are independent and not mutually exclusive events, then probability of A intersection B is equal to probability of A dot probability of B. So dear students, note that for mutually exclusive event, if here we have the union symbol, the probability of A union B, then replace the union symbol by addition and replace the intersection symbol by multiplication. But the main point is the difference between the events you see over here. union is replaced by addition. Union is replaced by addition. This is actually called the additional law. In the addition law, replace the union by addition, and you see over here this law. This is the addition law. Addition law have two cases. One is the probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. And this is the another case. Probability of A union B is equal to probability of A plus probability of B. So when the two events A and B are non-mutually exclusive event, we have this third term also. But when the two events are mutually exclusive event, we have now this term. So the probability of A or either B. Actually, we use the union in case of when we have two choice A or B. When the statement of the choice has the description, that is probability of event A or probability of event B. So in case of R, probability of A or B, probability of event A or probability of event B. Actually, this is the two choice. A is one choice and B is the another choice. So when we have in a problem, we have two choices and we have the choice probability of A or probability of B. So in case of R, OR, probability of A or probability of B. In this case, we use this union symbol, probability of A or probability of B. Then for the calculation of this probability, we replace this union by addition, and we have two terms, probability of A plus probability of B, when these two choices A and B are mutually exclusive event. But if these two choices A and B are non-mutually exclusive event, then we have this third term also in this addition law. And in the multiplication law, if the probability of one event has no effect on the probability of other event, then the event will be called independent event. So when the event are independent and are not mutually exclusive event, then probability of A intersection B is equal to probability of A dot probability of B. So when we use this intersection symbol, this is actually called the multiplication law. When we have two choices and between the choices we have and probability of A and probability of B. Sometimes we have R option, probability of A or probability of B. And sometimes we have the AND option, probability of A and probability of B. This is mean probability of both A and B. So when we have the AND option, for the AND option we use the intersection, and this intersection replaced by the multiplication, replaced by dot. And when A and B are independent and not mutually exclusive event, if these two are equally are mutually exclusive, then the probability of intersection B simply will be equal to 0. So for this case, for this law, these two events will be not mutually exclusive event. Not mutually exclusive event mean that these two events have some common outcome. So at least one common outcome, then in this case these two events are called mutually exclusive, not mutually exclusive events. So in this video lecture, these laws are very important. One law is that the probability of empty set will be equal to 0, probability of the sample space S will be equal to 1, and probability of the complement of an event A is equal to 1 minus probability of event A, because we know that probability of A union A complement is equal to probability of A plus probability of A complement, and this is actually probability of the sample space S, and the sample space probability is equal to 1. So we can easily prove that probability of A complement is equal to 1 minus probability of A. And another law which is called the addition law. Addition law, we use the addition law in case of when we have two choice, and for these two choice we have R option, probability of A or probability of B. So for the R option we use the union, and we replace the union by addition for the probability of A or probability of B. And in this case, when the two events A and B are non-mutually exclusive event, then probability of A and B will be equal to probability of A plus probability of B minus probability of A intersection B. So when A and B are mutually exclusive event, then this term will be equal to 0. So the addition law become probability of A union B. You see over here, probability of A union B will be equal to probability of A plus probability of B. And another important law is the multiplication law. When two events A and B are independent and not mutually exclusive event, then we use the multiplication law. We use for the AND option the multiplication law, probability of A and probability of B. In case of AND option, we use the intersection and replace the intersection by multiplication when the two events A and B are independent and are not mutually exclusive event. Then probability of A intersection B will be equal to probability of A dot probability of B. And now this is the end of this segment. Thank you. Allah Hafiz.